Good afternoon. Hear me all right?
Hello.
We'll wait just a few minutes for a few more people to join us. I'm sure we'll have a couple more join in. Thanks for joining with me today. There we go. My iPad is on low power mode, so it's trying to not stay awake. Go change my settings there. There we go. Take just a couple more minutes. Usually everyone gets here by 3:08 or so. Okay. Doesn't look like we're going to have anyone right at the moment, but we can go ahead and get started and have a little discussion. Um, so last week we finished up with our first section of material. How did you feel about the test? Oh, looks like my iPad went off again. See if we can get back into the in here. Okay. Elvira, do you have any comments about the test?
I honestly, I thought I was more prepared than I was actually prepared, and the way it wrote it out, I don't know if I even did it correctly, but the way how they have the exponents and stuff like that, I don't know, just the way it was set up, I thought it was going to be a little different, and so I found it a little bit challenging how to put in my answers. So
yeah, that's one of the biggest things that I see as far as inputting answers in the Blackboard that's complicated. I wish they had a better setup for math. You can do the equation editor, but sometimes that's not the best way to do things. So
I can't hear you. You're muffled.
I don't know why that would be. I'm
Right now it's better.
Is that better?
Yes.
Sorry about that. Yeah, one of my biggest frustrations with Blackboard's exams is the formatting on being able to enter math. You can do that a little bit better if you use the equation editor. And before we do the next test, I'll make sure that we go through. I'll sort of set up a test and the best way to enter. I regret that I didn't do that the first time. I've done that too. It seems like there's a little bit more help that can make a lot easier. How do I have left to be able to get all
Mr. Huckleby, I can't hear you.
I don't know why that.
It's like you're cutting out. It's like
I'm not sure if that's on my end then. Let me see.
Should I try connecting back?
Let me try something. Yeah, it seems like on my end that I'm getting really high feedback, but only when I turn up the volume on my other device. Let's see if join us. Okay, joining in. We'll see if that isolates. Kaylin, can you hear me?
Yes, I can.
Is it so? Second. All right, let's. Come on, screen share. Work with ability decided to update itself in the middle of our class. Elvira was having trouble hearing. Having that trouble, Caleb, or are you able to? I'm getting the sense that you are having trouble.
Kaylin, can you hear him, or is it just me?
It's cutting out, like, on and off. Not really.
Oh,
Okay.
okay.
Let me try and jump out of the meeting and back in, and we'll see if that fixes it.
Okay.
Okay.
Okay, can you hear me now?
Yeah.
Yes.
Is that a whole lot better or just a little bit better?
It's
Better
better.
so far. Yes.
Okay. Let's see if I can. Okay. So, sort of the discussion we were having before was on the formatting of the test and entering in answers. If you don't mind when you're not talking, if you just mute on your end so we don't get any feedback. So getting a little bit on mine. Oops. Can y'all still hear me okay?
Yes.
Yes.
Okay, very good. I was just worried that I once everything was muted, I couldn't hear you. Okay. So what I was saying was before we take our next exam, I will go through and make sure that we spend one of these sessions on how to enter in answers into Blackboard and making sure that you have a higher level of comfort with doing that. I know a few people had some issues with sharing their written work on the scratch paper and stuff. The easiest way that I've found to do that is to just take pictures of it and send it in. So yeah. Any other concerns about the test? Any other thoughts?
So I took pictures and emailed it to your email. Is that how we were supposed to do it, or wasn't like that?
No, that was perfect.
Oh, okay.
Absolutely
Okay.
exactly what you should have done. I've got a big stack of those and a big stack of exams to go through. I'm hoping that I have those completed by the end of this week.
Okay.
They just take a long, long time to grade. And I've got multiple classes to grade for, so that just makes the problem a little bit worse. But I'll get those out to y'all just as soon as we can. I know we're quickly approaching midterm, and I don't want anyone to not have an opportunity to drop if they need to. I'm hoping that we don't have to worry about that too much, but we'll cross that bridge when we get there. So this week we've started a new unit of things to discuss. We've been starting functions, and there are a few things in the last sections that we haven't had a chance to have one of these sessions for. So if y'all have any homework questions, I'll be glad to start working on those now and work through some examples for you if you have questions.
So I'm working on the assignments that due on the 15th. I kind of sort of understood a little bit on the assignments of the past ones that were supposed to be turned on the 9th. I did skip some because I didn't understand them. I don't want to have them on hand to do. But the ones that I'm having issues with is the ones with the graph and
Okay.
the tables of where what was. Why are they compatible? Why are they compatible? Like the X and Y.
Gotcha. Let me see if I can pull up that section. So I'm trying to find an example. I'm guessing you're talking about 3.1. Let's see if I can screenshot one. Copy it over here. Okay, how about this one? Does this relation in the table form a function, represent y as a function of x? Is that a function? Why or why not? Feel free to jump right in and tell me what your thoughts are. Well, when we're looking at whether something is a function or not, we need the x's mapped to one and only one y value. So we can't have x's repeat. So we have three different x values, right? Do any of the x values repeat?
No. So they can't repeating as far as the same number?
Right, the same number. There are
Okay.
no x values that repeat. So
Correct.
no x values are repeated. So y is a function of x. Okay, let's try another one. What about this example? Does this relation represented in table form represent y as a function of x?
I would say yes with the instructions you gave.
Do we have repeated x values? So our ordered pairs in this relation would be 17, 3, 15, 11, and 15, 5. Is that a function? The answer is no, because we cannot have repeated x values. This 15 has two different values of y. So because 15 is paired with two different y values, this relation is not a function. Okay. Let's try one with a graph and use the vertical line test. So is this a function? The vertical line test says that if I draw a vertical line through the graph of a relation and it crosses that graph more than once, any line you pick, if you cross more than once, it's not a function. This is not a function. Move that out of the way because it fails the vertical line test? Questions about that one? Okay, let's try another one. We're sort of on a roll when it comes to doing the homework, so let's keep going. Does this one pass the vertical line test? Take a second and look at it, and I'll let y'all answer and tell me why or why not a function. So what do you think? Is this a function or not?
I think that it is a function
Okay. And why do you think it's a function?
because it doesn't pass through like two of the thingies together, like the lines together.
So there's not a vertical line that I can draw here that will pass through that blue line more than once. So I agree with you. This is a function. So because we have no lines that pass through the graph more than once, this relation is a function. Okay, let's try another. I'm just progressing through the homework and seeing what we get. See if you can answer this one. Use the vertical line test to determine whether this one is a function.
I think that it's a function again
Okay, and why do you think it's a function?
because you can't draw a line and it goes through it twice.
Exactly, same as before. There are no vertical lines. Lines that pass through the graph more than once. So this graph is a function. Very good. Let's try some equations and see if those are functions. So what about the first one? Y equals x to the fourth. Is that a function of x? If you'll remember back to the video, the only time we have issues with y being a function of x is when we have things where we have to take a square root and you get a plus or minus part. We don't get a plus or minus part because we have this already in terms of x. So this is a function. What about the next one? Well, we have 8x squared plus y is equal to 2. Can we solve that for just y? Well, let's write it out. 8x squared plus y is equal to 2. Can we solve for y? What would we do? We can subtract 8x squared from both sides, and we get y is equal to negative 8x squared plus 2. Is that a function? Function of y as a function
Yes.
of... It is. This is a function. What about 7x plus y squared is equal to negative 4? Can we solve that for y? I think we can. Let's subtract 7x from both sides. And we get y squared is equal to negative 7x minus 4. How do we get rid of the y squared stuff?
That's representing a 1, right? 1 square. So do we divide?
So this is actually a variable raised to the second power, y squared. So the way we undo the squaring is to take a square root. So we take the square root of both sides. But remember, when you take the square root of both sides, you get y is equal to the positive square root of negative 7x minus 4, and y is equal to the negative square root of negative 7x minus 4. So is that a function? Well, the answer is no, because we have two different representations of y. So you'll have repeated x values. This is not a function. What about the next one? What about y is equal to the square root of 1 minus x squared? Is that a function? Well, it's already in terms of y. So what do you think? Is that...
I would say yes.
Yes, this is a function.
I have a question.
Okay.
So is there a way to like see if it's a function or not without solving for it, or no?
So generally speaking, I would be afraid to say that you can write it as a function of a variable without saying this is, without solving it. Now, at the level that I'm at, after having seen lots and lots of functions, I can look and see that there will be problems with something like this. I know there's going to be some square root stuff, but until you actually have performed that operation a number of times, you won't just see it based on looking at it. Now, if you were to graph that, in fact, let's do that. Let's see if we can. I'm going to turn off screen sharing for a moment. And then I'm going to go to Desmos, see if I can share again. I can share my screen. So this actually probably is the easiest way to look at it. If I put 7x plus y is equal to -4. Oops. That should be y squared. Okay. So that's what our graph of 7x plus y squared looks like. Can you tell from looking at that that it's not a function?
Yes.
If I draw a vertical line through that, and I can't actually do that because I'm in a browser, not the. Let's see if we can say x equals, say, -5. There's a vertical line, passes through it twice. That's not a function. So that's a tool that could be useful for you. Again, you wouldn't have that necessarily on a test, but you definitely need to be able to see why that happens. And then this is the last one. Is that a function?
No.
So your initial thought is no. But the closer in I get, the more you can see that it doesn't matter how high we get on this equation. I'll zoom out. It looks like that line touches, right? So I'm going to zoom out where I have big, big numbers here. So that's like 1,000,000 on the. I'm going to zoom in as far as I can zoom in. I have to get in very. I don't know if we'll even be able to see it. We'll have to get in so close. So it actually won't let me get close enough. But the reality is that this never actually touches the y-axis. Which I know is sort of crazy, but that it has an asymptote there, which we'll talk about those probably at the end of the semester if we get to them. But what happens is this tries as hard as it can to get to that axis, but it never gets there. Let me go back to notability, and we'll take a look at the actual equation. -3xy equals 1. Can I solve this for y? Well, I can divide both sides by -3. Let's rewrite that. And I get xy is equal to -1/3. Then I can divide both sides by x, and I get y is equal to -1/3x. That's the only way we can write that in terms of y. It can only be 1 over 3x. Now, as x gets really, really small, we're dividing by smaller and smaller and smaller numbers, so those numbers get really huge, but they never can equal 0. Y can never be 0. So because that happens, because there's that domain restriction, which we sort of talk about in the next section, it can pass the vertical line test. The only line that would come close to touching more than once would be the line at x equals 0, but the graph never touches that line. So this is a function. Questions about those? Let's talk about evaluating a function. Let's do an example where we evaluate a function. Oops. Made it a little too big. We want to evaluate f of x is equal to negative 3x squared plus 10x minus 3. And we want to start evaluating at f of negative 3. How do we do that?
Would you plug it into all the x, where all the x's are at?
Right, we plug in, and what is that we plug in though?
The negative 3?
Right, we plug in a negative 3 everywhere we see an x. Okay. So using our order of operations, what do we do first?
I would do the exponent, the 2 on the negative 3.
Right, we do the
Square.
exponent first. So negative 3 squared, what is negative 3 squared?
9.
9, okay. And I'll just copy down the rest. What do we do next?
Multiply.
We multiply, we do our multiplications. Negative 3 times 9 is negative 27 plus a 10 times negative 3. So actually it's minus 30 minus 3. So we have negative 27 minus 30, which is negative 57, minus 3, which is negative 60. So f of negative 3 is equal to negative 60. Questions about how we do that? Let's try another one. Let's do f, keep switching to the highlighter, f of 1. What do we do in this case? Anybody? We do the same thing we did before, which is, let me move my toolbar out of here. Come on. we plug in 1, our input value right here, in for everywhere we have an x. So -3, again, it keeps switching on me. -3 times 1 squared plus 10 times 1 minus 3. Again, we have to perform the exponent part first. So 1 squared is just 1. So -3 times 1 is -3 plus 10 times 1, which is 10 minus 3. We have -3 plus 10, which is 7, minus 3 is 4. So f of 1 is equal to 4. Let's try something a little more complicated than just adding in a value. Same function this time, except we want to evaluate it at f of a. How do we do this one? Well, we just plug in a everywhere we see an x. And there's not a whole lot of simplifying we can do. We just get -3a squared plus 10a minus 3.
So I
What?
have a question. I'm sorry.
Okay. No, you're good. Go ahead.
Oh, not on that one. I'm sorry. Go ahead. Finish, and I will ask you.
No, that's the end of that one.
Okay. So I got. There was on 3.1 function and function notation, which was the problem was let f(x) equal negative, and it's in parentheses, which is number 10. 2 plus x, and then it closed. I got the first part right, but the second part was wrong, and I don't understand what I did wrong.
Okay, read that function to me again. So let f of x equal.
So let f of x equals a negative, and then it has the
Brackets?
The bracket 2 plus x, and then it closed the bracket. And this is evaluate f bracket -5 bracket. That one I got correct. And then it's the other one that says solve for the x equals -4. That's the one I got wrong.
So what it says, so you got this one, you got to the answer, and then it says solve f of x equals what value?
Solve for equals -4. Yes.
So,
correct.
So did you plug in -4 for x?
I did. Did I do that?
So what we're saying here is f of x is equal to -4, not x. This is f of x. So when it says to solve f of x is equal to -4, what you do is you plug in -4 for f of x, and you say -4 is equal to -2 plus x, which is why it says x is equal, because we're looking for x.
That's why. Okay.
So what you do is you go -4 is equal to, let's distribute the negative, -2 minus x. And then we can add 2 to both sides. So we have -2 is equal to -x. Divide both sides by -1. X would be equal to 2. Does that make a little more sense?
Yes, it does, because I did nothing of that. And I was like good looking on YouTube and everything. I was like, what am I doing wrong? Okay.
So
Okay, I got
basically what we're doing here is, instead of plugging in this input into the function here, we've got the output of the function, and we need to go back here to find what the input was. So you have x's, you plug those into this function machine, and you get out outputs. So you have inputs, a function, and outputs. So you were given an output, and you have to push it back through the function to get the input. And there's a technique that we probably will not do in this class. I can't remember if that's in the syllabus or not. There's actually a way that you can take a function and find another function that reverses all of those processes. It's called an inverse. Well, very good. It looks like we've come to the end of our road for today, but we'll be back on Thursday at the same time on the same channel, and we'll work through some more of these examples from these sections. We'll do some more 3.1, and then we'll probably have some time for 3.2 stuff and any other questions y'all may have as you work through your homework.
Okay. Thank you so much.
You're very welcome. And if you have questions as you go through it, please feel free to email me as you go, and I'll respond to you, and we'll get you through with the homework.
Okay. Thank you so much.
Y'all have a great Tuesday, and I'll look forward to seeing y'all on Thursday.